Okay. All right, so let's go over these problems. Again, I'll make an answer key and I'll post it to Schoology. And I'm recording this also. So for the first 4 questions, it should be pretty straightforward. I'm just going to kind of do it in my head. And of course, if I'm wrong, let me know. But I believe that's just going to be -10, 13, 7, 1, 5, 2, -1, 2, and 3. We're good? Okay, good. I can add. So that's good. Okay, it's just adding. And then for the next one, be careful because you're subtracting. So I believe that's going to be 14, -7, -5, because you're going B to A, -3, -3, 6, 11, -6, and 3. We're good? Okay, cool. For 3, awesome, because here, I'm just going to kind of position it this way. So for 3, you're multiplying B by -7, so I'm going to do -14, -21, -7, 7, -7, -28, -35, 14, and -21. Okay, cool. And then here, wow, it's bring me just my head. Let's see how good I am here. -2, 11, 3, 5. Someone just want to blur out their answers, and I'll just see if you got it right. Okay, well, sounds good. You guys are in unison. I'm doing number 4, yes. So number 4, you got to multiply A by 1/2, and B by 2, and then of course add them up. And let's see. Well, let me see if the masses were right. And looks like so far so good for the second row. Okay, so careless. It happens. Happens best of us. Yeah, this is correct. 4 is correct. Okay, cool. Let's keep on moving. Not really. Just kidding. Let's move on to this page, the second page. Through 5 should be pretty straightforward. That's just straight up multiplication. You're multiplying by 3, so it's a scalar. So that's going to be, of course, 9360, -312. Cool. Okay. Multiplications, yeah, good. Because that's a 3 by 3. Wait, no, that would work. Yeah, that would work. So E is a 3 by 3, right? And A is a 3 by 2. Yeah, because you got to, so rows, right? Rows are horizontal. So, all right, so we got to do this multiplication. So how that would work is you'd multiply E with A. So you got to do 1, 4, -2 with that column. So that's going to be 3 plus 8 plus 2. And then you got to do the first row of E with the second column, which would be 1, 0, and -8. And then you got to do the second row with all that jazz. So that's 6, 2, -6. Add up. Then you go to the second row of the second column, which would be 2, 0, 24. Then rinse and repeat the third row of E with the 2 columns. Positive 24. And then you do a 0, 6, 0, 0, 6, 0. And then 0, 0, 0. Okay, that's easy. So final answer for EA should be 13, -7, 2, 26, 6, and 0. Okay, good. All right. Which number? Sorry.
1 through 4.
Sure. I don't want to do them over again, so I'm just doing this. See if I get back. I think I'll be okay. Oof. All right. There's 3 and 4. Okay, Aris, and then 1 and 2 should be pretty straightforward.
Yeah, I think I go for this today. It's okay.
No, it just takes a few seconds. Hold on. This is the beauty about Zoom, so I can do this pretty easily. There we go. See, we got them right there.
Yeah.
Okay, cool. All right. Okay, for number 7, B times C. B is a 2 by 4, and C is a 4 by 1. So multiplication actually should be pretty straightforward. The final answer would be a 2 by 1. I'll distribute the 2 in a little bit. But if you do the multiplication, you should get 2, 2, 0, -8, 2, 2, 0, -8. Add it up, of course, and then you get -4, 0, 0, and -2. So it's 2 on the outside, -4, and -6. Distribute, you get -8 and -12. Yes. Yes. Because you have a 2 by 4 being multiplied to a 4 by 1. So the outer dimensions will be your dimensions of your product. You must reverse it. You must have C times B. Because you're doing E times C, right? So you're doing this row in this column, which is that. You're doing this second row B, which is column of C, which is all. So those line up. So we're able to do multiplication. Actually, C times B wouldn't make any sense. I think we're good. That's like this. Yeah, no, you got it. No, but you didn't add these up. Yeah, because whenever you combine a row and a column, that counts as one element. But if we have like multiple pairs, multiply those pairs, then add up those products. That's what you gotta do. Okay, and then DD, that's a 2 by 2, the 2 by 2. The 2 by 2, the 2 by 2. You got 3, 2, -1, 4, 3, 2. Of course. What's wrong with that? Okay. I'm just gonna do this in my head. You should get 7. What was the other one? Sorry. Sounds good to me.
I got 7, 14, -7, 14.
Yeah, it should be 14 at the end. Yeah, I agree. Should be 14 at the end. Yeah. Yeah, I mean, obviously it's arithmetic, right? Okay, we're good? Cool. And again, I'll share this video so you can see the process, and of course, I'll have an answer key prepared as well. For GF, gets a 3 by 2 with a 2 by 2. All right. One more of these here. FG would not work, but GF would work. GF would work. Because you do this with this, which is 2. And then you get 14. Then you have 3. and 26. You have 0 and 8. Are we okay with that one? Yep. Yeah, because GF's a 3 by 2. And then F's a 2 by 2, so the inner dimensions match up. And half of G, that's easy. That's just a 1, half, 3 halves, negative half, 0, and negative 2. Easy peasy for that one. For 11, the answer is no.
Yeah.
Because if you reverse, either you can't do it or you get a different result. Like if you have like say like HI, if you did HI on H, you would get answers. And I think that's what they ask you to do actually. Great. Well, we could go through it. It's gonna take a while, so I'm not gonna do it. I'm getting a little lazy, I'm sorry. But hopefully you got different answers. I trust you guys could do multiplication, so let's move on. Yeah, we're gonna do the last page, yeah. Okay, here's how the last page works. Let me start with 13. I'll go back to 12 in a sec. And I'm gonna get a highlighter out here. You just have to line them up. So like, see how like these are in the upper left corner? Those equal each other. See how these are in the upper right corner? Those equal each other, which of course they do. See how these in the lower left corner? Those equal each other. These in the lower right corner? Those equal each other. So then you can make equations, right? When you make your equations, you're gonna say 3x minus 3 equals 0, and y minus 1 equals 5y minus 5. That's all. That's all you're doing. X is 1, and y is also 1. That's it. Nope, y. Whoops. Let me take that back. Now, number 12, I know we had an example like this, and I kind of said there was a typo. Actually, I think it was intended to be like this. The answer is not possible. And here's the reason why. What are the dimensions of the left matrix? A 2 by 1, right? What are the dimensions of the right matrix? When the dimensions are different, they're not equivalent. So you can't draw the same dimensions that you do with 13. 13, I was able to find corresponding elements. Upper left square, next square, more left square, more right square. That's intuitive, right? The problem is that you only have 2 elements here, 4 elements here. There's not a match. Because 2 by 1 and 2 by 2 are totally different dimensions. And we're not multiplying. I don't care what their dimensions are. Multiplying, just comparing 2 matrices. If the 2 matrices don't have precisely the same rows and columns, you can't do a comparison. So it's just not possible. That's really what we should have said for 12. It's not possible. 12 is not possible. Yeah, is that good? Sure. Sure. Yep. Yeah, because the other numbers are going to cancel out anyway. Yeah. Sure. Yep. Yeah, because whatever like for example here you could say 3x minus 2z equals negative 22. You could say that. That's possible. Or you could say half y equals y plus 3 plus w. You could say that. I guess number 12 you could do that. I mean, okay, so let me guess. For number 12, did you say 3x equals 2y plus 7? Yeah. It's just weird because they don't have the same dimensions. But if you did, I mean, the way I taught it in class, because I think you were bringing tests at that time. I think I should like.
I was not. I was scared.
How were you?
I was sitting right here.
On Wednesday?
Yeah.
Oh, I was saying Monday. Sorry.
Monday I was here.
Okay. Yeah, because we didn't talk about Monday. We were sulking in our misery. Anyway, but yeah, that's the way I did do it. But it's just to me, it's just still weird because they're not the same dimensions. But yeah, really the proper way to look at it is to is really just line them up. Like say, I would say like 3x equals 0, negative 2z equals negative 22. But that's really what you're supposed to be doing. Half y equals y plus 3, and y plus 3 equals w. Like that's what you really should be doing. because you're lining up all the proper elements, right? So X is 0, Z is 11, Y will be, I think, -6, and therefore W is -3. Sure. And you can do something similar for this one here. It does? Oh my God. What am I thinking? Sheesh. Yes. Thank you. That is correct. Right. Yeah, and then here, what's that? I mean, we're not doing coordinates, so that's why that's not really relevant. Yeah. Yeah, because it's a quadratic. To x plus 5 and x plus 9. And of course, y. You have this. Y should be -6, I believe. Yep, good. Okay. Okay. We're good? Okay, cool. So we're gonna move on, new topic. Let me pass out the stuff.
I'll move it right now.
My cousin was like gambling in Vegas, and he was playing casino on
Like, I'm this.
I know. I was like, oh my gosh.
Well, you want to hear something similarly crazy? So when my brother got married in 2010, we were in Vegas. So we had a 4-day wedding. It was like crazy. So the day after the wedding, go up here kind of walking around. I've been to Vegas many times, so well, let me pause this actually. Well, actually, that's fine. I don't care. I'll show them the video. So anyway, so I kind of ducked out because, like, people were just like walking around the strip. I was like, look, I've seen the strip, mate. I don't need to do this touristy stuff, right? So I go into the Bellagio and I decided to play some blackjack, right? So I'm sitting at the table, and at the other end of the table is one of my former students. So, and it's a student I tutored at Palo Alto High School. Like, I tutored him for SAT, PST, and the kid did great. He was National Merit Scholar, had a full ride to Arizona State. He chose to go to a school where he would get like full tuition paid. And I'm kind of looking over, and like I was like, is that you, Brooke? And then like he looks at me, he's like, Gus, and so we went up playing together for about a good hour or so. Like, he was there for his brother's bachelor party, so he was like 22 at the time. So, but that's like when people ask, like, do you ever run into students? That's probably one of the craziest. I actually did run into another student flying back. I was actually in Vegas for a conference, so I was there for business. And I was flying back, and at the airport, I saw another former student. And look, at she had been up all night and was partying. Like, she was so embarrassed. I was like getting breakfast, and she was like trying to hide. So I run into students in the weirdest places. So anyway, and I've run into students actually in other countries and also in Hawaii at times. So yeah, it's a joke. My wife always says we'll run into people we know when we travel. Anyway, all right, let's keep moving here. Wait, where? Oh, European, Europeans. Wow. Okay. I mean, usually you run into people sporting events. Like if you go to a Giants game or Niners game or that is pretty random. Yeah, that's pretty random. Yeah, we happened to be on the same flight to Portugal of a family who actually knew, we both knew the same Sacred Heart family.
Really?
And we went up running into him. And then like we were on the train and I went up like friending the dad.
Yeah.
And then he asked me, so how do you know this person? Because we had a common friend. And it was a crazy story that we both, and so it has like 5 hour train ride. We're just like sharing. We're all so small, you know, it's so crazy. Yeah.
It's actually crazy. Like, you can pretty much find a method that's any.
Well, this one actually I will bring. All right, so let's talk more about matrices, guys. All right, so here's the deal, why we feel so adamant about teaching this topic. So I did talk on Wednesday that like a lot of databases are organized using matrices, and it's just something that, you know, if you do computer science or data science, it's good to understand how matrices are, how they behave and how to add, subtract, multiply. But mathematically speaking, matrices are very powerful for solving system equations. Personally, I would actually prefer doing system equations this way, as opposed to doing the old school way where like you had to substitute or do elimination. This actually, if you have like a crazy system, like say you have like 5 equations, 5 variables, you would actually use the matrices. You would not do it by hand if you have like more than 3 equations. Even 3 equations, 3 variables, hard to do by hand. Which I think sometimes we have. You guys had, maybe had you guys have algebra 2, I don't know. So it just gives you a lot of efficiency when it comes to solving system of equations. Now, first off, what is a system of equations? Very easy, just a bunch of equations, right, with a bunch of variables. That's a system. So see, you have 3 equations, 3 variables. That's a system. And actually, you guys had that on number 3 of our last test, right? The one we talked about that didn't go so hot. So you guys, you know, you have to do substitutions. That's what's happening here. Now, we're going to organize this in a matrix. So if you look at the next matrix, what does that matrix represent right now? The one that I'm circling in green. What does that represent? 3 by 3. But what does it represent? Let me rephrase my question. How is it correlated to the system of equations up above? How are these related? If you look at the coefficients. Yeah, what are the coefficients of the first equation? 1, 1, 1. Coefficient of the second equation, 3, 2, 4, and 2, 1, 1, right? So that's called the coefficient matrix. So what I'm doing is I'm going to organize my system into matrices. So I have a coefficient matrix. Also, you're going to have a matrix equation. A matrix equation is when you simply take your system and you treat it like a multiplication, right? If you think about it, that's a 3 by 3. And that's a 3 by 1. So that's a coefficient matrix. That's a variable matrix. And of course, that's a constant matrix. And what's going to happen is that if I were to multiply the coefficient matrix with the variable matrix, I'd wind up getting all this, and with each of these numbers here. We're going to actually explore this type of equation next week. I'll use it for sure with finance. Well, Thursday, I don't know which day. Maybe one of those 2 days. But I know next week we're going to talk about that. What I really want to focus on for today is something called an augmented matrix. An augmented matrix is when you take all the numbers you see, so the coefficients and the constants, and you put it all into one matrix. So see how like the last column, -1, 16, 19, that's on the other side of the equation. That's the last column here. We're going to be working with that today. So we're going to put all our information into an augmented matrix, and then we're going to do some sort of magic, I'll call it. It's called Gauss-Jordan elimination, but we're going to do some sort of kind of cool technique that'll help us solve for X, Y, and Z. So the whole goal for today, we want to solve these equations here. We're going to solve these equations, which I think is more efficient than doing by the old school way of substitution, which you guys probably did in algebra 2 or in middle school, I don't know. And how we're actually going to do it, there's an algorithm that goes to it. You're going to wind up swapping positions. You're going to wind up multiplying one row by a certain number. You're going to wind up adding, subtracting scalar multiples of one row with another row. There's going to be a lot of different things we're going to do to make this happen. So let me show you an example. And you guys kind of just sit back and watch. Then I'll have you copy it down. And then we'll do another one together. So here's, actually, definitely you should at least write this down first. So what you're going to do is create an augmented matrix. And once I finish this, we'll start homework. I hope we get homework done before the weekend, so you don't have any anything to do over the weekend except for preparing for the homework quiz on Tuesday. Yes, exactly, right. So I'm gonna do this first. Okay, this is our start. Now, our end goal, because it's always going to know what are we trying to do here? What's our end goal here? Our end goal is to make it look like this. Our end goal is to make first row 1, 0, 0, and whatever x equals. 0, 1, 0, whatever y equals. 0, 0, 1, whatever z equals. Just so you know, the last column's not going to be letters. It's going to be what x, y, and z are numerically. So these are going to be some random numbers here in the last row. But if you get the first 3 columns look like this, then what you're saying is that, oh, x equals this number, y equals that number, z equals that number. So that's going to solve the system for us. But we have to kind of do some sort of, I like to call it magic, make this happen. So let's get going. And this part right now, just sit back, and relax. Don't talk people down because I might make some mistakes. So what I'm going to do first is probably try to eliminate. Let me think here. I'm going to do this first. I'm going to do R3 plus R1. And by the way, this is R1, this is R2, and this is R3. If I add R3 to R1, so I add this row, what's going to happen? You have 3, what happens here? 2, and then 18, right? Yep. So you get 1, 0, 2, 18. Not yet. Just watch for now. And then, well, I'm also going to do this. I'm going to do 4 R3 plus R2. And do 4 R3. I'm not sure why, actually. Hold on a sec. Actually, I take it back. Let's hold off on that. Okay. We'll hold off on that for now. Okay, so you're going to have 3, -2, -4, 16. 2, -1, 1, 19. Okay, there we go. Okay. So I just added R3 to R1. So what I did is I augmented them. I changed how the first row looks. Now the first row looks like that by adding R3 to R1. Okay, next up, I'm going to do, what should I do next? Let me do this. Let me do 2. No, I take it back. Let's do 3 R1 plus R2 and 2. Actually, again, don't copy this down because I'm gonna make some mistakes here. So 3 R1 minus R2 and 2 R1 minus R3. There we go. So I'm going to keep the first row as is. And now I'm going to have, so if I do 3 R1 minus R2, that's 3 minus 3, right? That goes away. So that becomes 0.
you pick the numbers based on what you?
Yeah, that's what I did, right. I'm trying to find ways to cancel stuff out. Then the next one's going to be positive 2. Because I'm doing 3 times 0 minus negative 2. Then I have 6 minus negative 4, which is 10. And of course, I'll have 54 minus 16, which is what? 54 minus 16 is 38. I know, right? And then this one, I'm going to do 2r1 minus r3. So I get 0 again. And then I get 1. And then I get 4 minus 1, which is 3. And I get 36 minus 19, which is 17. Okay. Next up, I could do this. I'm going to keep the top row as is. And let's get rid of the 1 in the bottom row. So I'm going to keep the second row as is also. 0, 2. Actually, while I'm at it, no, I'll just keep it as is for now. 0, 2, 10, 38. I'll recap it. Then I'm going to do half R2 minus R3. Why am I doing that? Because you still get 0 here. But if I take half of 2, that's 1. 1 minus 1 goes away. 5 minus 3, and 19 minus 17. So I wind up getting, that goes away. I have 5 minus 3, which is 2, and 19 minus 17, which is also 2. Okay, I think I'm almost there. Then I'm going to do, let me think here. I'm going to do negative half R3 plus R1. If I do that, I get 0, 0. No, so I get 1. Let me go back. I get 1, 0. Actually, hold on. Let me backtrack a little bit. Sorry about that. I'm going to negative R3 plus R1. What's going to happen here, I'll still get 1. I'll get 0 here. Then that becomes 0. And that becomes 16. Simultaneously, I'm going to take half of R3, which is 0, 0, 1, 1. And of course, I have 0, 2, 10, and 38. Okay. Almost there. I'm going to do negative 10 R3 plus R2. If I do that, I get 1, 0, 0, 16. 0, 2. But then I have, that becomes 0. And that becomes 28. And 0, 0, 1, 0. Let's make sure I've done this correctly here. So when all's said and done, one of the things that I think I made mistakes somewhere along the way. I think one is supposed to be negative. Hold on. Yeah, something's a little fishy here. Hold on. I have R3 plus R1. Okay. Well, I know, I think I made a mistake somewhere along the way, but here's what happens. You wind up getting x equals 16, 2y equals 28, and z equals 1, or y equals 14. I think where I made a mistake, I think my x supposed to be negative 16. That's the only thing where I think I might have made an error. 32. So let's take a look here. If you look at the third equation, that works out, right? Because I have 2 times 16 minus 14 plus 1, and that will be 19. That will be 19 with the numbers I chose. So 16, 14, and 1.
So the remaining stuff you think you divide.
Right, exactly. There is another technique that I like better than this one. This is just to show you one technique. If I do this one, it's 3 times 16 minus 2 times 14 minus 4 times 1. That's 48 minus 28 minus 4. Yeah, that gets you 16. The only thing is that the first equation doesn't work. I don't know what went wrong with that one. So that's where I'm a little flustered. Not sure why that is not working out.
How do you think like honestly
It's really just it's kind of I don't say random, but it's a little bit of trial and error, like trying to figure out like which one matches up. So yeah, the only thing is that I have a calculator that actually does I have a program. Let me just see what the calculator spits out, because for some reason it's not working with the first equation. I don't know why. Give me 1 sec here. Solve 3 equations, 3 variables. 1, 1, 1, negative 1. 3, negative 2, negative 4, 16. 2, negative 1, 1, 19. Okay, the numbers came out different. I'm not sure where I went wrong here. Let me see if I spot my error. Give me 1 sec. I may have copied these down wrong too. R3 plus R1. Oh my goodness. Okay, guys. You guys see my error? I'll give someone 2 points extra credit to see my error. Okay. Look over here. I did R3 plus R1. What's R3 plus what's 2 plus 1? Oh goodness, that was a no, because I told you to look. Yeah, exactly. You're supposed to spawn 2 seconds. Yeah, gosh darn it. Okay, well, hold on. So that's 3. So then when I do R3 R1, that actually becomes 9. Hold on. So I'm gonna fix this really quickly here. Yeah, I kind of messed that one up really hard. So let's do another one, but we're gonna do it together. We're gonna do it more slowly. So sorry, I messed that one up. Let's do. It's okay. Because no, don't write any of that down. Now let's write this down. Okay, that was my warm up. I know because I have a program that does it. The answer is supposed to be 4, -8, and 3. So I messed up. Omar, go ahead. That's next week. Yeah, that requires another technique. Okay, it's okay. This is for real. Let's do this for real now. I'm going to be more careful. 3. Trust me, it does work. Just I made a very stupid error. Okay, we're gonna do this for real now. Because now you know what I'm trying to do. Okay. One thing we probably, no, I don't want to do fractions just yet. So again, you want to get something like this. You want the end results to look like this: 1, 0, 0, 0, 1, 0, 0, 0, 1, and then some numbers in the last column. That's what you want, right? That's our goal. Okay. So let's work this out. I'm going to do let's do 2R1 plus R2. Okay, let's do 2R1 Yep. So I'm going to keep the first row as is. I'm going to keep the last row as is. Okay. Go. Why don't you guys do 2R1 plus R2? Tell me what you get. 2R1 plus R2. Oh, sorry. 2R1 plus 3R2. I take it back. 2R1 plus 3R2. Yep. 2R1 plus 3R2. Okay, so you should get 0 for the first one. Okay. Then you should get what? Next one. So 1. Oh, wait. Hold on a sec. Negative 2 plus 9. Yes, you get 7, right? 15 minus 2? 13? Yeah, okay, good. All right. Okay, so we're making progress, right? Now the next thing I'm going to do, I'm going to do I'm going to do R1. Actually, I'm going to do R2 plus R1. Sorry, R2 plus R3. Okay, why do I think I'm doing R2 plus R3? What's going to cancel? But R2 plus R3, what's going to cancel? Good. So I have 0, negative 2, 7, and 13. So 5, 0, 6, and 16. Good. Much better. Okay. Next up, I'm going to do R1. Actually, let me take it back. Yeah, I could, but then then you get a 3 there, so I was trying to be careful. Actually, let's do this. Let's do R2 plus R1. Yeah, first row. So I'm going to keep the second and third rows the same. So R2 plus R1, you get 3, 0, 6, and 12. Okay, starting to look pretty good. Then I'm going to do R3 minus R1. What's going to happen when I do R3 minus R1? Two, 0, 0, and 4. 0, negative 2, 7, and 13. R3 minus R1. And I got 5, 0, 6, 16. Now, at this point, this is what I'm going to do at this point. Because we could keep going, but I think we have enough to solve, right? So yes, what we see in green is kind of the end goal, but I think we have enough to actually solve. Because you guys are going to go a little nuts if I keep asking you to go further. So I know that this right here means 2x equals 4. So of course x equals 2, right? So it means that this is 5x plus 6z equals 16. Well, what is x? 10, right? I mean, what is x? 2. Yeah, the last row. Because that the first row represents x. The second, sorry, the first column represents x. Second column represents y. Third column represents z. And the last column represents all the constants. So then z should be 1. you solve that one. And then lastly, negative 2y plus 7z, or 7 times 1, equals 13. So y is going to be negative 3, I think. Negative 3, right, right. And let me use my little program here. Yep. Oof, got it. Okay, so let's back up a little bit. Let me explain what just happened. Okay, so I got all this in the matrix, right? That was easy, not hard. This is the part where you have to use the same critical thing. Not, I mean, you can see like the wheels are turning my head on. So I'm not 100% sure what I'm doing. I'm just taking a leap of faith, right? And of course, I made a mistake in number 1, and that's what goes in my face. That's good. I'm glad I made a mistake from you guys because I'm humans back in stage, right? You know, I've done this for a long time. Okay. So I saw an opportunity to get rid of this here, right? So I did. Oh, sorry, I got rid of the negative 2 here. So I just did 2R1 plus 3R2 to get rid of the negative 2 here, right? And that's what happened here. Then I saw an opportunity to get rid of negative 2 and 2 here. So I added R2 to R3 and I did. And I saw another opportunity to maybe get rid of well, what do I get rid of next? Sorry, that's not. Oh, R2 and R1, get rid of these two here, right? So I did that. I did R2 plus R1, get rid of that too. That's like another opportunity to look at these sixes here. Did R3 minus R1 and did that. At this point, I know what X equals 2x equals 4, X is 2. And I substituted, solve for Z, because Z is 1. Substitute for Z, solve for Y, and I got the answer. And it worked out. Okay, let's try it one more time. We have you guys kind of tell me what to do, then we'll do some practice. Or you'll do the homework, I suppose. Okay. Okay. We're gonna do two equated two variables. Probably should start with that, I suppose. Don't always start with a really big one. Okay, so you're gonna have this 1, 6, negative 1/9, and 0, 1, 1, and 15. Kind of up to you what you want to do, but you could do this. I'm gonna do 6. Actually, example 3. Actually, I'll have you guys help me out here. You have example 3? You're funny. All right. Okay. So anyway, what if I want to get rid of this 1 here? I want to get rid of this 1 here. What would I do to row 1 and row 2 and row 1? Good. Yes. So let's do 6R1 minus R2. And I probably should start at this one. I don't know why I started the harder ones. Okay, so I'm gonna keep the first row as is. You know, not a big deal. Keep the first row like it is. Now, if you do 6R1, that's going to be 1 minus 1, which is, if it helps, you could probably just say that's 1, negative 2/3, and 0. So if I do 1 minus 1, that's 0. Negative 2/3 minus 1, which is negative 5/3. What was that? Sorry?
So if you have 3 9 or 6 9 over or minus.
So that's just fractions. That's just negative 6 minus 1.
6 minus.
So it's negative 2/3 minus 3/3. It's negative 5/3. And then, of course, 6 times 0 minus 15 is negative 15. So now I can immediately say that, oh, okay, well, negative 5/3 y equals negative 15. if I solve for y, I wind up getting n divided by -5. You should get 9, I think. Yeah. And then you have 1/6x minus 1/9 times 9 equals 0. So 1/6x equals 1. X equals 6. And that totally makes sense. 6 plus 9 is 15. 1/6 times 6 minus 1/9 times 9. That totally makes sense.
Yep. That wasn't too bad. That actually was pretty. I should start with that one. I don't like the harder ones too.
So that's what you're doing. You're making a matrix, and you're kind of just doing a combination of rows. So I'll work through the other ones to make sure I have them worked out, and then I'll share with you guys. But so now you guys can start the homework. Or, I mean, when do we get at 1:10? Or if you need a brain break, that's fine too. If you don't want to start the homework, that's totally fine also. But the homework is right here. So 1, 2, 3, 4, 5, 6. Yeah, there's 6 problems. If you want to try and make a couple, but I'll work these out right now too. I'll stop the video.